This video is sponsored by Remarkable. Hello and welcome to this episode of Night Sky News with me, astrophysicist Dr. Becky. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about JWST's view of Uranus, the brightest of all time gamma ray burst that's been detected, and a supermassive black hole that's been ejected from the center of its galaxy, plus much more. There's chapter markers down here if you want to skip ahead to any specific news story, and any scientific papers I mention are all going to be linked in the video description down below if you want to check them out. I'm clearly not at home in my normal filming space. I'm in Toronto because I was at a conference at the Perimeter Institute in Waterloo, Ontario, and then next week I'm at a conference in Huntsville, Alabama. So bear with me if the video and audio isn't up to its usual scratch. I'm in quite an echoey space here. But without any further ado, let's kick things off and start by looking up. All right, first up, on the 23rd of April, we're going to have a crescent moon, aka a toenail moon, pairing up with a very bright Venus in the west for a few hours after sunset. Now, you might have noticed Venus, even if you're living in a big city, just in the west after sunset. It's incredibly bright, so it's hard to miss. And it just seems to hang there at the minute. But if you're not sure what you're looking for, then when the moon's pairing it up with it on the 23rd of April, it's the perfect opportunity to find it. So look for the moon in the few hours after sunset. Just below it will be the very bright Venus, around about 3 fingers away if you hold your arm at arm's length. So the perfect pairing, especially for any beginner astrophotographers out there. Then by the 25th of April, the moon phase will have got bigger. It'll have risen higher in the sky to pair up with Mars. So because they're higher up, they're going to hang around for a lot longer in the sky, around about twice as long as Venus does. Mars is not as bright as Venus, but it does have that characteristic reddish color, so it makes it easier to pick out from all of the background stars. But again, if you're not sure what you're looking for, then the moon being close is definitely going to help. Towards the horizon, you'll also find Betelgeuse, the red giant star in the constellation of Orion, just above Orion's belt. We're slowly losing Orion from our skies now as we sweep around to the other side of the sun on Earth's orbit, so catch a last glimpse of Orion while you still can. Next up, on the 8th of May, a treat for those in the Eastern Hemisphere, a partial penumbral lunar eclipse. So let's break all those terms down, starting with lunar eclipse. A lunar eclipse is when the Earth passes between the sun and the moon, and the Earth casts a shadow on the moon's surface. But the Earth's shadow is not solid because of its atmosphere, so it has a fuzzy edge. So this is where the penumbral part of the eclipse comes in. The umbra is the very center of the Earth's shadow, and when the moon passes through this is when it turns red in a full lunar eclipse, often referred to as a blood moon, whereas the penumbra is the fuzzy outside. This eclipse is also classed as partial because the moon doesn't fully pass into the Earth's shadow. So there can be a slight sliver of it still illuminated on the edge. And this will be fully visible across Asia, Australia, the Pacific Islands, most of southern Africa, and partially visible for those in northern Africa and Europe. I'll pop a link in the description below where you can put in your location and see what the eclipse will look like for you and what time to look. If you do go out to watch the lunar eclipse, then keep an eye out for meteors as well, shooting stars streaking across the sky, especially if you're in the southern hemisphere, because the peak of the Eta Aquarids meteor shower is around about the 5th and 6th of May, at the same time as the lunar eclipse. This is one of the meteor showers caused by Earth passing through the dusty debris left behind by Halley's Comet. And all these little pieces of dust and rock burn up in the Earth's atmosphere. And for the Eta Aquarids, can cause up to 50 meteors per hour in the darkest of skies, where you can see both the bright and the faintest ones. You know, that's nearly a meteor per minute. Now, the radiant of the Eta Aquarids meteor shower, so where the meteors all appear to be shooting away from, is in the constellation of Aquarius, which rises highest in the southern hemisphere. It only just comes above the horizon in the early morning for those of us in the northern hemisphere. So that means in the northern hemisphere, only half the meteors are going to be visible because the rest are just going to shoot below the horizon. So the view for us is not as good as for those in the southern hemisphere. The best time to look, as I said, is going to be early morning. Problem is the moon is going to be full around about the 5th or 6th, so it's going to be really bright in the sky, washing out all but the brightest of meteors. But if you look during the lunar eclipse, then that should dim the moon. So if you can time it right, you should have this like perfect storm for seeing the meteor shower and the lunar eclipse at the same time, perhaps just before dawn for those of you in the southeast, so Indonesia, Australia, and New Zealand. And as always, if you snap any pictures of the meteor shower, send them my way over on social media because I'd always love to see them. Back to something for everybody now, although sticking with the morning sky because Saturn is back. It disappeared from our sky at the end of last year, 2022, as it went round the opposite side of the sun from Earth. But it's now visible just before sunrise. And on the 13th of May, the crescent moon is very close by, again helping you to pick it out since it will be faint against the brightening sky before dawn. Those of you closer to the equator are going to have an easier time picking this out because it's going to be much higher above the horizon for you. All right, that's it for looking up at the night sky. But before we chat about what's been happening in space news, I want to say a big thank you to Remarkable for sponsoring this week's video.
The Remarkable 2 is the next generation paper tablet. As a scientist, my research notebook is the most important thing in my work life. It's where I keep track of my thoughts, ideas, findings, and other research papers that I've read. Now, throughout my PhD, I used a paper notebook, but quickly found that when I was away at a conference or working from home, they were useless to me because I couldn't look something up that I'd written down in a previous notebook, which were all stored in my office. Now, a lot of my colleagues were using note-taking apps, which I tried, but I missed the freedom of being able to scribble and let my mind wander. That's when I discovered Remarkable 2, the digital notebook that allows me to be fully focused when I'm working with no distractions. But most importantly, I can now store my notes in the cloud so I can access them wherever I happen to be, whether that's at a conference, on a field trip up a mountain to use a telescope, or just working from home. Plus, I found that I'm so much more organized than I was before, like with the ability to sort all my notes into folders. So like my different research projects now have separate folders, and any notes I take during seminars can be in a separate folder. Plus, I can add PDFs of research papers I'm reading and scribble on them and keep them organized rather than just in a pile of printouts on my desk. I put off the switch to digital just for so long because I thought nothing could replace a paper notebook, but the Remarkable 2 tablet feels just like paper. There's a resistance to it when you write. It doesn't have that click and clack of technology that can be so aggravating to you and others working around you. So if you want to transform the way you work with digital notes and get organized, you can discover more about the Remarkable 2 at the link in the video description below.
All right, let's come back down to Earth now and chat about what's been happening in space news in the past month. All right, so this month we saw the launch of the European Space Agency's ESA's JUICE mission to Jupiter. One day later than originally planned due to a lightning risk, but it is now making the very long and looping journey to Jupiter with its planned arrival in July 2031. NASA also announced the astronauts for the Artemis II mission. You've got pilot Victor J. Glover, mission specialist Christina Koch, mission specialist Jeremy Hansen, and Commander Reed Wiseman. Artemis II is essentially going to do the exact same thing as Artemis I did, but this time with a crew on board. So Artemis I demonstrated that the newly designed craft could actually loop around the moon. So Artemis II is going to do exactly the same thing, but with a crew on board this time, and it's set to launch in November 2024. Now, before we get to exciting black hole news, we should stick in the solar system for a little bit because JWST has taken yet another stunning image of a planet in our solar system. So first we had that image of Jupiter, then of Neptune, and now it's the turn of Uranus. Revealed in exquisite detail, both details in the planet's atmosphere and also its faint rings that were first seen by Voyager 2 in its flyby in 1986. Now remember, JWST is an infrared telescope. So this is an infrared image, therefore it's a false color image. What they do is they take images through different filters that only let through certain ranges of wavelengths of light. So what you've got here is you've got one image that's been taken through a filter letting through only 1.4 micron wavelength of light, which has been colored blue, and then a second image that's been taken letting through only a longer infrared wavelength at 3 microns that's been colored orange. So hotter regions giving off more of these shorter wavelengths, so showing up bluer here in this image, and cooler regions giving off the longer wavelengths are going to appear more of that orangey yellow color. Now, the most obvious feature in this image is this really bright region on Uranus's pole. Now, Uranus spins on its side with more than a 90-degree tilt compared to the sun's north pole. So it has one light side that experiences summer for half of its orbit and one dark side that experiences a very dark winter for the other half of its orbit. And this bright patch seems to appear on the pole each summer and then disappear again in Uranus's autumn. Not much is known about this bright patch though, because we haven't observed it sort of appearing and disappearing that many times because Uranus's year is so long. The time it takes to orbit the sun is 84 Earth years.
It's been 84 years.
So we don't have enough data on this seasonal variation of this feature, but it's hoping that JWST is going to shed some light on it, whether it is just clouds thickening in the atmosphere, or whether it's a haze of sort of dusty molecules that have been dredged up from low in Uranus's atmosphere because of the fact that sunlight is hitting the pole, and then that sets up some sort of convection again in the summer years of Uranus. So where you have heat rising and sort of cold falling, and that dredges up those molecules. If you zoom out on this image, you can see that JWST also picked up some of Uranus's moons as well, with just a 12-minute exposure in total. I cannot stress enough how remarkable it is that JWST is capable of doing this with something that is relatively bright, right? It's an object in our own solar system when it's been designed with the sensitivity in mind for detecting incredibly faint, distant galaxies in the universe. It's a very clever use of the instruments by the science team, and it's just the tip of the iceberg when it comes to solar system studies with JWST. We have these images, more data is going to be collected, and I can't wait to see what the results are when the analysis is all done. Next up, I want to talk about a big discovery, the brightest gamma ray burst of all time, or the B.O.A.T, a play on GOAT, greatest of all time, that's particularly used in sports. Now, gamma ray bursts are incredibly energetic bursts of light or radiation that have been observed in distant galaxies since their accidental discovery in the late 60s. And they can last anywhere from a few milliseconds to hours, when gamma rays, the most energetic form of light with the highest wavelength, are given off. Then after that, there's usually an afterglow as well, where you get the longer wavelengths of light. So everything from X-ray through infrared, visible light, and down to radio wavelengths. And just to give you some context on how insanely bright gamma ray bursts actually are, they can give out more energy in the space of a few milliseconds than the sun will in its entire life. Yeah. Now, we think they're coming from supernova, when a star runs out of fuel and implodes, throwing its outer layers into space, and the core collapses into a neutron star or a black hole. In some cases, you can get jets that are fired from the poles of the supernova that generate these gamma rays, and then as they interact with the surroundings, produce the afterglow. Now, this new gamma ray burst that's been detected by Williams and collaborators is GRB 221009A. And the numbers in the name here just reflect what date the gamma ray burst was detected on. So in this case, it was the first gamma ray burst detected on the 9th of October, 2022. And it was more than 10 times brighter than any other gamma ray burst that's been detected before by the Swift Observatory. It was so bright that it completely saturated the instruments on the telescope. Like, it blinded the telescope, essentially. So much that it didn't really get a reading of how bright it actually was. That had to be reconstructed from the afterglow that was observed in X-rays by the Fermi telescope. And what's really interesting is that the properties of the afterglow of this gamma ray burst cannot be explained by our best hypothesis we have for how these gamma ray bursts are generated. So none of our models we have can fit this afterglow. So theorists are going to have to, go and put their thinking caps on now to try and explain what made this gamma ray burst so bright and so different. Now, of course, a claim like the brightest of all time also needs evidence as well. So Burns and collaborators made sure to grab all the archival observations of gamma ray bursts available to test that claim, and found it was indeed the brightest of all time, with over 10 times more total intrinsic energy than previous brightest of all time gamma ray burst claimants. And of course, with JWST in operation now, it would be rude not to observe the afterglow in the infrared with JWST. That's what Levan and collaborators have documented here, not just JWST observations in the infrared, but also Hubble Space Telescope observations in the visible wavelength range as well. This makes it the very first gamma ray burst observed by JWST as well. And the observations were taken around about 12 days after the burst. And it revealed a fairly featureless spectrum, right? So where you get this trace of how much light of each wavelength you receive. And it had very little change from a lower resolution infrared spectrum taken just 12 hours after the initial burst. That's really weird, because if the spectrum doesn't change that much, that suggests that the supernova that produced this gamma ray burst is really faint, despite the gamma ray burst being the brightest of all time. Now, ideally, what you'd do is you'd find the actual supernova in the galaxy itself, which you can try and do with the Hubble Space Telescope. But the thing is, the galaxy is very, very distant, so the image is not the best. But what you can see is that the galaxy sort of slightly edge onto us. We're looking at it through the disk of the galaxy. And galaxy disks have a lot of dust in them that blocks a lot of the visible light, making isolating the supernova location in this galaxy very difficult. Plus, this galaxy is in a region of sky that's just above our own galaxies. The Milky Way is a very dusty disk as well, so there's even more absorption of light going on, making the problem of identifying if there is a supernova there in that galaxy even worse. We will keep looking. There's more observations planned. It could be just that the supernova is very faint, but it could also be maybe a little bit more of an exciting scenario where maybe this star sort of skipped supernova and just directly collapsed straight down into a black hole, but somehow also, gave off a gamma ray burst in that process as well before becoming the black hole. So, there's lots of exciting hypotheses that could explain this, but more data is going to be needed. But one thing Levan and collaborators did point out was that the galaxy doesn't appear any different from any other galaxies that have had gamma ray bursts that we've detected, which rules out the hypothesis that it could be, a property of the galaxy itself that's resulted in why this gamma ray burst is the brightest of all time. We know it's not to do with the galaxy, it's clearly something to do with the star that produced this gamma ray burst. So while these papers, which have all been published in one fell swoop about the discovery of GRB 221009A and, doing the very initial analysis, more work is still needed to understand this GRB fully, but you will be glad to know that there are both Hubble Space Telescope and JWST observations planned in the next month to observe this further. Another big news story this week, ultramassive, if you will, was the discovery of an ultramassive black hole at 32 billion times the mass of the sun. I was so excited by this research that I couldn't wait to put it in Night Sky News. So I actually made a whole video on it already, how it was found with a brand new method and what it means for our understanding of black hole growth. So check that out if you're interested. I'll link it in the video description down below. And finally, sticking on the theme of black holes, because Van Dokkum and collaborators this month announced the discovery of what they reckon is a supermassive black hole that has been ejected from the center of its galaxy. Now, this was a completely serendipitous discovery that was found in an image taken by the Hubble Space Telescope for a different project entirely, one that's focused on understanding dwarf galaxies that seem to contain no dark matter. I've actually covered those ongoing efforts before in a Night Sky News video from November 2020. Again, if you want to check that out, I'll link it below for you. But in the HST images collected for this project, Van Dokkum and collaborators spotted this long, thin feature in the image that looked like nothing we've seen before. And if something like that happens, you've got two questions to answer. The first one is it real? Is it actually a real object, or have you just detected some weird artifact of perhaps the image processing, sort of all the steps you do to remove noise, for example? Or is it just something like a cosmic ray that's just a fluke that's hit the detector and caused this streak. What you do then to check that is you go back and look at if it's been seen in all the different images that you took at slightly different wavelengths of this object. And when Van Dock and collaborators did that, they found that yes, it's there in all of these different filter images, so it's definitely a real thing. Then that brings you to the second question. How far away is this weird thing that you've found? Is it, at the same distance as stars in our own galaxy? So it's in sort of the foreground of the image. Or is it incredibly distant, the same distance as very, very distant galaxies in the background of the image? If it's that distant, it could be that it's something like a gravitational lens, for example. So a background galaxy that's had its light bent so that it appears to be stretched out in shape by some sort of galaxy in the foreground acting as a lens in curving space. Although if you look at the feature they found, the feature is very long and straight. It's not curved. So they've been pretty sure early on that that's not what it was, which makes this object even weirder. Turns out it's at the exact same distance as this galaxy here. It has the same redshift. So its light has been stretched the same amount by the expansion of the universe. So it's traveled the same distance through the universe to us. So it's somehow associated with this galaxy. And with this sort of straight line shot, the most likely scenario that Van Dock and collaborators could come up with is that something has been ejected from this galaxy and left a trail in its wake so that we can see it. The question is, what? Well, now you got to study the object itself, look at its properties to work out what it could possibly be. And one thing you can look at is you can look for emission from specific molecules that are giving out light at very specific wavelengths because the electrons in the atoms have been excited. So some source of energy like light has impacted with the electrons in an atom, transferred energy to them, causing an electron to jump to a higher orbit. It's not supposed to be there though, so it drops down and gives out light that's always at the exact same wavelength or color, which is unique to that element. It's set by quantum mechanics because only certain orbits are allowed for the electrons in an atom, and the difference in energy between those orbits is always exactly the same. So you always give out the exact same energy of light, i.e. the exact same wavelength of light every single time. The more energy that's transferred to a big collection of atoms, the more light will be given out. Plus, some atoms need more energy to make these electron transition jumps than others. For example, you need a lot more energy to excite the electrons in oxygen than you do in hydrogen. So if you compare how much light do you detect at the wavelengths from oxygen versus hydrogen and find that you have more light from oxygen, then you know you must have an incredibly energetic process going on in this feature to give you more excitation of oxygen than of hydrogen. Something like very intense star formation, for example, can give you this. Or from the light given off by materials spiraling around a black hole as it's heated up and accelerated to huge speeds. If that's the case, you do usually also get X-ray emission, which they don't see for this feature. But what they do see is that it's got a similar ratio of that oxygen to hydrogen emission as shocked gas, either from a supernova explosion or from, again, an accreting supermassive black hole that sort of burped up some material from the regions surrounding it in what's known as an outflow or a jet. In either case, something is impacting with the gas, compressing it so that it informs stars at a really intense rate, and it's also exciting the gas as it goes as well, causing this excitation. But for the ratios of oxygen to hydrogen seen here, we also need something traveling at incredibly high speeds to get the level of shocks and star formation that are seen. So to explain this, Van Dock and collaborators suggest that two galaxies merged together in the past, and the supermassive black holes in the center of them also slowly sloshed together and spiraled together, which is a process that we see in simulations all the time. It takes around 1 billion years after two galaxies merge for the two supermassive black holes to merge in the center as well, just because they really do slowly spiral together. But Van Dock and collaborators reckon that in this case, in that time, around about 1 billion years or so, another galaxy has come in and merged, adding another supermassive black hole to the mix, which was unstable, resulting in like a slingshot effect where the black holes are completely ejected from the galaxy, moving incredibly fast, causing shocks and star formation in their wake, leaving that trail that we see. There's also another bright spot on the other side of the galaxy that the researchers reckon is the binary black hole system that was ejected the other side. Assuming that's what's happening, you can then look at the color of the stars in that long straight feature that you see, that sort of wake that's been left by this supermassive black hole. And from that, you can work out their age to get at, how long ago the supermassive black hole was ejected, which Van Dokkum and collaborators work out was around about 39 million years ago at a velocity of 1,600 kilometers a second, which is absolutely insanely huge. It's a really compelling idea, helped by the fact that we don't see any evidence of an actively growing black hole in the center of the galaxy like you would expect at the end of a merger. Now, it could just be that those signs, that incredibly bright light we'd expect like in X-rays, for example, or ultraviolet, perhaps they're just hidden by dust in the center of the galaxy, or perhaps that growth has actually stopped now as well post-merger. Like 40 million years later, it's like, I've eaten all the material you gave me already, and it's sort of winked out and switched off. Ideally, the next steps would therefore be to get X-ray data with the Chandra telescope, for example, on this galaxy and on this feature. Look in the very center to see if there is actually a supermassive black hole there. Look at the ends of these features to see if perhaps, there are growing supermassive black holes there, taking in some material from the surroundings where they've now been ejected. Plus also JWST data would help here, because it would help pierce through any dust to see if we could see that sort of bright point source of light that is that accretion disk that's swirling around the supermassive black hole. And ideally, you would find more of these things as well. Perhaps you could train a machine to look for them in archival data, more Hubble Space Telescope data, or especially in images from NASA's Nancy Grace Roman Space Telescope set to launch by 2027, which is very similar in size to the Hubble Space Telescope. So it's going to give very comparable images like what we get with Hubble already. But instead of being a telescope that's sort of, like at the beck and call of the community, and the fact that, you have to write a proposal to say, this is what I want to use Hubble for my specific science case. And there's a panel that decides, okay, we're going to do all of these little different science projects. The Nancy Grace Roman telescope will be a survey telescope. So what that means is that it will try and observe the entire sky sort of night after night, building up sort of these little, sort of like a mosaic of what the entire sky looks like. So you can imagine the volume of data we're going to get from that, right? Like imagine having images like this, but for the entire sky. It's going to be absolutely revolutionary, this telescope. We're going to find a lot of things, hopefully, in that data, but especially maybe some more features like this, where it could be an ejected supermassive black hole. And then we can learn, how common is this? What scenario results in the supermassive black hole being ejected to? And how does it affect the galaxy? Fun fact, it probably affects it less than you might think. I've actually made a video about this before in context of our galaxy, the Milky Way, and why it'd be fine if you wanted to remove the supermassive black hole from the center of the Milky Way, if you want to check that out. But of course, that's all based on our understanding of gravity. So we would still want to check that and sort of observe some galaxies where this had actually happened. All right, that's it for night sky news for this month. As always, if you snap any pictures of the night sky, or you see any news stories that you'd like me to explain in a future night sky news video, send them my way over on social media. But until next time, everybody, happy stargazing. Oh, I can't have the aircon on while I'm filming. It says it's 27 degrees in here. So roughly sort of just over one a minute or so. No, not just over one a minute. One just over every... Don't mean more than one a minute. I mean like just over a minute you will get a meteor. It's hard, words harder. Why do I keep saying month? Weird month. With just a 12-minute... Oh! I don't know what happened to my voice there. Slowly cooked while I film Night Sky News. There's a new one. There is a siren outside. Because we're in the middle of a city. Beep, random car outside. God, city noises and you're filming, eh? I'll wait. I will wait. I will wait for you. And they can last anywhere from a few milliseconds to years. Years? Hours. Be able to elucidate what's going on. Elucidate? I feel like sometimes I just use words and I think I know what they mean, but I don't know. And my phone is over here, so I can't look it up. It's this sun on my back. I feel like I should have like sun cream on to protect me from all this UVA that's getting through these windows. That then leads you to the second question. Second question. What about second question? What about second extended edition? The second question. No, it's just the hair on the back of my neck just needs to get off for a second. We'll film this like this and hope no one notices that I'm just piling all my hair on one side.